So we want to think a little more deeply about energy conservation. And so let's consider the work done by gravity. And let's say that gravity is acting in the y direction. So we'll specify, right, the work is the integral of the force over the distance. So let's do minus mg j hat. So our convention is that the negative y direction is the direction in which the force of gravity is pulling, and we'll do the dot product with dy, right, because dx and dz doesn't contribute anything, and so this is from r1 to some r2, or some y1 to some y2 if you want. So this is minus mgy from r1 to r2, which is mgr1 minus mgr2. And let's consider r1 equal to r2. So if r1 equals to r2, so we could be at ground level. We launch an object up and it comes back to ground. And so r1 is equal to r2. And so what follows from this is that the work is 0 because both of these are the same. It's also true that work equals difference in kinetic energy. And so what follows from that is that K final minus K initial is equal to 0. And so the kinetic energy, when the object reaches ground again, must be the initial kinetic energy. So we launch an object up with speed v naught, and so it has initial kinetic energy 1/2 m v naught squared, let's say. Then the final kinetic energy is the same, and we have energy conservation. So this is E is conserved, and we know that we can write this force as minus the gradient of a potential. And so when we do that, we have U1 plus K1 potential plus kinetic at one point equals potential plus kinetic at another point. And so if R2 is equal to R1, then U2 is equal to U1, and these cancel out, and we have K1 equals K2, and we see that, right? So K final equals K initial. We again have the same kinetic energy. So, but let's now consider doing this calculation, but as a function of time, because we want to introduce a time-dependent force and see what that does to energy conservation. So let's go through the same calculation, but parameterized differently, such that the dy depends on time. So as a function of time, this will look like, right, what is y as a function of, what is the dy in terms of time? Well, the y function is y naught plus v naught t minus 1/2 gt squared. And so the dy is equal to v naught dt minus g times 2t. In dt, we divide by 2. We get rid of the 2. So the work in this case is written as minus mg j hat. So the integral, now we want from one time to another time, dotted with a dy written in terms of time. So we have v naught dt minus gt dt j hat, and this is minus mg times v naught t minus g t squared over 2 from t1 to t2. which is minus mg v naught t2 plus mg v naught t1 plus mg squared over 2 t2 squared minus mg squared over 2 t1 squared. And if we say that t1 equals 0, right, that's where we start. So t1 equals 0. T2, so T2 is going to be given by this equation, just like we had the dy be given by that equation. So that's going to be when it reaches, so at t equals 0, y is equal to y naught. So that could be the R1. Let's just make that 0. So this would look like 0 equals 0 plus v naught times that t2 minus 1/2 g t2 squared. And so t2 is equal to 2 v naught over g. That's when it comes back to ground, to the initial position. Of course, we could have chosen it to be anything else. It'll just be y equals y naught, and they will cancel each other out, and we'll end up at the same place. So the work, we'll get the same work. It must be 0. Let's see that. So we have minus mg v naught times this t2, which is 2 v naught over g. This is 0. So our next term is this, and this is 0 plus m g squared over 2. And we're going to square this, so we get a 4 v naught squared over g. And this is equal to minus 2m v naught squared plus 2m v naught squared, which of course is equal to 0. So the next thing that we'll do is to imagine that the force actually changes with time, so it's not a constant. And so we'll do the same thing. We'll evaluate the work, and we'll find that the work for the object to go up and come back down to the same place will not be 0, and therefore that it's not possible to have something like this, and therefore this will not be true.